Good morning, BYW students. It's Mr. O'Sullivan. Today we're going to be learning about the properties of numbers. But before we go into the properties of numbers, if you look through this handout, there really isn't that much computation going on. And that's because there isn't any computation today. All we're doing is identifying properties. So, the learning target for today is I can apply the properties of numbers by identifying the property used in a mathematical statement. So here's the reason why what we're learning today is so important. It's because these properties are the reason math works out the way that it does. This tells us that we can change order, we can group different things, we can multiply, we can add whatever. That's all it's doing today. For instance, mathematicians didn't realize anything times 0 is 0, and that's a property. So those are the things we're going to be looking at today. So today, please relax, take your notes, and let's begin. The first property we're going to be looking at is called the commutative property. So I'm going to zoom in. This is your commutative property, and I'm just going to give you a heads up. Here's a trick to remember the commutative property. The first two letters are C and O. It's not the initials of my name. I mean, it is the initials of my name, but that's not why it's there. It's because it stands for changing order. So whenever you see CO, I want you to think in this course right now, change order. And remember, you should be taking your notes on your iPad. That way you can submit to iLearn later on. So here's the thing. In math, you can actually change the order of a lot of operations. Just can't change them for a few. So if you change the order of two numbers being added or multiplied together, you'll get the same answer. That's multiplied. I'm just doing that big letter X for multiplied. You're going to get the same answer. So here's why that works. Well, if I have 3 and a 5, that gives me 8. And if I have a 5 and a 3, that also gives me 8. So I just basically changed around my order. That is what the commutative property states. Another example of the commutative property is 5 times 7. Well, 5 times 7 is 35. Well, guess what? 7 times 5 is also 35. That is the commutative property. Below, you'll see some non-examples, some of the non-examples. Here's what we mean by it not working. I mean, you're still going to get the same result on both sides. You're still going to get a 12. But when we do the commutative property, we want to basically just move it to the left or to the right. So for instance, if I moved my 4 and my 3, that would be commutative. But what I did was I moved my 5 from the end, all the way to the front, which is not allowed. But that is going to make sense in our next property. Also, subtraction is not commutative, and the reason why is, well, 6 minus 7 is -1, but if I change the order and do 7 minus 6, I get a +1, which is not the same answer. Okay, now we're going to look at our associative property. Whenever you think of associative, I want you to think of associates. So think of us. We are in a business school. We're supposed to be working together. So is going to be associates. So the way things are grouped together. So for instance, you can be sitting with Anaya or Camille or Manaya. For instance, I could be sitting with Miss Townsend, or I could be sitting with Miss Jimenez. So if you change which two of the three numbers are in parentheses, so whenever you see parentheses and no number attached to the parentheses, this is a sign you are dealing with the associative property. So whenever you change which of the 2 or 3 numbers are in parentheses, when all of them are being added or multiplied, you'll get the same answer. So if I look at my examples where I have my 1 and my 2 in the parentheses plus a 3, I can basically associate my 2 with my 3 right here. That's an example of the associative property, where I'm just basically moving my parentheses. All my numbers are still in the exact same order, I'm just moving my parentheses. Now look at an example of multiplication. I have my parentheses around my 5 and my 9. Well, guess what? Now they're around my 3 and my 5. And then below are some examples of not the associative property. You see, I just changed the order. I did my commutative right here. I basically made my 3 go from the second to first. And then this is also not an example of the associative property. I'm changing the order of everything, just doing a mishmash. So distributive property is our next property. You've seen distributive property multiple times, and I'm going to tell you a heads up. It just means to multiply. Just means to multiply. So you're just going to multiply. So if you've ever played the game Angry Birds, think of the blue bird. The blue bird, you shoot up into the air, and when you hit your screen, it explodes into 3 little tiny birds, and then it tries to hit the little pigs. The numbers on the inside of your parentheses are the pigs. The number on the outside is your Angry Bird. So here's how we go from 3 times 4 plus 7 to 12 plus 21. I draw an arrow from my 3 to my 4, and I multiply. That gives me a 12. I draw an arrow from my 3 to my 7. I multiply. That gives me a 21. That is an example of the distributive property. You'll see down below, to the right, that we have 4 minus 8 times 6. That's an example of backwards distribution. We typically have the term always in front, but we rarely write it like this. So it's the exact same thing. I draw my 6 to my 4. What do I get? 24. Draw my 6 to my 8. Get 48. The reason why it's not a positive 48 is because if I look at the inside of my parentheses, my 8 is being subtracted, so I need to carry that subtraction through. We don't typically write the 6 after the parentheses. If you want, you can write it as 6 times 4 minus 8, and you'll still get the exact same answer. I distribute. I get 24. Distribute. 6 times 8, 48. Exact same thing. And then we have our examples of the non-examples. Basically, these are not distribution. You do not distribute your 3. You do not distribute your 3. This is a 1 in front of your parentheses. So no, this just doesn't work. Do not fall for these mistakes. Now we're going on to the next part. Now we're going to be learning about the additive identity. Here is an example of the additive identity. It's just basically when the number doesn't change. It's you. You stay the same. The number doesn't change. So when the number doesn't change, you have to ask yourself, what am I adding to it? Do you know? You have an example of the additive identity whenever you are adding by 0. And the reason why is, 1 second, I have to erase that. Because anything plus 0 is itself. So if I do 5 plus 0, that's 5. If I do 0 plus 1,876, guess what? That's also 1,876. Now, that was the additive identity. The multiplicative identity is the exact same thing, but instead of adding by 0, we are multiplying by a 1. So the number that gets multiplied to anything without changing its identity is the number 1. So if I do 4 times 1, that'll be a 4. If I do 1 times 8, that'll be an 8. That's the multiplicative identity. The number that gets multiplied to anything without changing its identity is 1. These are some examples. So if I have, say, A times 1, like the letter A times 1, that would just be A. Inverse. Whenever you hear the word inverse in our course, I want you to think of canceling out. Canceling out. So let's write that in. Canceling out. So basically, a number opposite of the one given. Number opposite of the one given. 1 second. so that when added together, they cancel out to make 0. So whenever you end up getting an equal 0, and they're the exact same numbers, just the signs are different, that's an example of the additive inverse. So for instance, if I start with, say, a positive 3, it will be a negative 3. If I start with a negative 4, it'll be a positive 4. So one of the things I like to do is I like to always write out this little picture. Plus becomes minus, minus becomes plus. And those are the examples right here. Now we have 2 more, and then we are done, and then you're going to do some independent practice. The multiplicative inverse. A number which, when flipped to the given number, will cancel out, which will result in a 1. So I'm flipping. So if I start with a 6, I make it a 1 over 6, because this is really a 6 over 1. I put my 6 downstairs, and I put my 1 upstairs. And I multiply, and I get a 1. It basically says that my numerator will cancel out with my denominator will cancel out with my numerator. So if I start out with 5/3, like I do here, and if I flip it, I'll put my 5 downstairs, and my 3 up. 3's cancel, 5's cancel. When I got nothing left, I got a 1. That is the multiplicative inverse. And last but not least, we have the zero product property. The zero product property simply states anything times 0, it's 0. So if I have 6 times 0, it's a 0. If I have 20 times 0, it's 0. If I have a million, bajillion, gazillion times 0, it's 0. That is the zero product property. So today you learned about all these properties and all these rules. So here's what your next task is. Myself, Miss Townsend, and Miss Jimenez would like you to complete a number properties worksheet. Here's how it'll work. If you would like to do it on a separate sheet of paper, you may, but if you are blended, you cannot hand us in the paper. You would have to take a picture and attach it to iLearn. If you are remote, you may do it on the PDF that's on iLearn. If you're blended, you may do it on the PDF that's on iLearn, but make sure that you submit your work to iLearn. If you have any questions, email myself, Miss Townsend, or Miss Jimenez. Have a great, great day.